So we go ahead and get started. So today we're going to finish up chapter 6 on files, and then we're going to get to exceptions, which are important. Okay, so the homework that was due today, I went ahead and last night I had several questions about stuff. So I went ahead and put out a video where I did basically chapter 6 problem 1. If you looked, you found I also did chapter 6 problem 3, which is actually on the homework. So if you looked at that video, you got homework help. And 4 is very similar to that. We can start when this pops up and actually do that real quick. So let's do 4 since 3 I basically did on the video for 6.1. Okay, so problem 4 asks you to go through a file of names. Note that you can edit your file directly from within idle if you want. You don't have to, but you can. So there's a name.txt there. So you have 4 names there. So for this problem, we want to open up the file. We're going to do our end file is equal to open. The file name is going to be names.txt. Open it for read mode. Okay. I'm going to do, you can do it this way. We can do a while if you want. This works as well. I'm going to go through, and each time all we're going to do is increase the counter. So before we get into this, we have to let our C be equal to 0. And every time through, C plus equals 1, or C equals C plus 1, whichever you prefer. That's all we need to do. And then in file.close. And then print out. There were C names in the file. Okay, that should be it. You have actual comments, of course. There were 4 names in the file, which there in fact were 4 names in the file. The questions on that one before we go forward. If you don't get this, you're probably not going to get anything else we talked about today. So the next thing we're going to talk about, and this is section 6.3, is the idea of processing records. Okay, so I'm going to go ahead and pop up Excel here real quick just to give you a clue as to what we're talking about. It's really common in any kind of situation that you may have something like a name, like an ID, and like a department. We're going to get that example here in a minute. Okay, so these together make up a record, right? So one person here this is the record for Bob, okay? If we have another person, that's another record. So a record in this sense goes horizontally, okay? And then we refer to each of these items as fields, okay? So name is a field, and if there's more than one person here, then each person will have an entry in each of the fields, okay? So again, row 5 is a record, row 6 is a record, but name is a field, ID is a field, and department. So that's where we're headed. And when this comes up a lot in computer science, and we tend to, if we're going to do this, okay, we're going to share the screen. No one saw that in the video. We're most likely going to need a database. We talked before about why we don't do the direct access files. Okay? And the reason being a direct access file, if you didn't get all that trouble, you're probably going to do it. There is a category file called comma delimited files, which is one field, comma, another field on each line. It's also pretty common. We'll get to that later, but we don't know how to handle that yet. So for right now, what we're going to do, we're just going to put every field in its own line of the file. Okay. And as long as we always work in groups of however many fields we have, a record at a time, we should be okay. So we're going to do here, this is the program 613 on page 312. Okay, to set up some records. Okay. So we're going to start, we're going to ask them how many employees there are, the intent, input, employees. That's out of the way, so it's not bothering us. Okay. And we're now going to open a file. We can call it in file, out file, whatever, but we're going to go ahead and call this employee file is equal to open employees.txt. Now, when we're opening it here, I'm going to open it in write mode this time because I know there's stuff out there, so I want to overwrite. But in general, the append mode is safer. Append mode, if there's nothing, it will create a new file, but if there is stuff, it starts putting it at the end. Okay. So this is definitely going to create a new file. Okay. So we've opened up the file for writing. So now we have to get. So we're going to actually loop through the employees. Get the date. Okay. So we're going to have for C in range from 1, because we're going to say employee 1, employee 2. That's going to make this up to number of employees plus 1. So if there are 4 employees, it's going to go 1 through 4. Okay? Because remember, it stops 1 before this. Okay. So we're inside of there. Again, we want to deal with all of the records at once. We're going to have 3 records in this one. We're going to have, 3 fields. We're going to have a name, we're going to have an employee number, and we're going to have a department. Okay. So we're going to, inside of this, we can say something like print, enter the data for employee C. That's where we're going to get the 1, 2, 3. Okay. And then we're going to say name is equal to input. Name. Okay. We're going to set the ID equal to the input ID. We're making the assumption the ID could be numbers and letters, so we're going to keep it as a string. We're not going to do any calculations with it, so there's no reason to ever convert it to even if it's all numbers. Department is going to be equal to the input department. And again, we may want to put some tabs here. Make our program a little bit nicer. So this is going to go through for however many employees that there are. It's going to create a new file, and it's going to go through and allow the input of the information. Okay. I'm going to go ahead and put a print statement in here just to kind of show some differences between the employees. In fact, if you want, you can even put some kind of line separator. Whatever you want to make it look a little better. Okay. So once we have entered the information, we want to go ahead and write it to the file. Okay, so we're going to write to the file. So we're going to start with the name. We're going to go with the emp file dot write name plus the new line character. Okay. And then we're going to do emp file dot write ID plus a new line character. And then the emp file write part plus the new line character. Okay. So again, that's for each of the employees that we have. And that should be it. Okay, so when we're down here, we can close the file. Okay. So from here, we're going to say emp file close. We can also say something if you want, like num emps records were written. Just to give some more context for the user. Okay. So if I run this, and that's really ugly, if you get the idea. Let's say there are 2 employees. There's Bob. There's an ID of 1, 2, 3, 4. He works in engineering. Okay, and you see the little line there just kind of gives us some separation. So the date for employee 2. In fact, a blank line on top and above that could have been nice also. Alice has an ID of 2, 3, 4, 5. For department programming. And it says here 2 records were written to the employees of PXC. Looks really official, right? Looks like a real program. That's the goal. To have your programs look like real programs. Okay. No, the goal is your programs to be real programs, not just look like real programs. Okay. So we've now written to that file. We can open up again within idle. You have to go to all files or it's not going to show. So look at that. There's the data that I just created. Okay. So I'm going to, when I start it up again, when I start it up again, it's going to be here. So if I want to go through and print them or do whatever I want to do, I can go through and it's going to go in this order. Okay. Do that there for reference. So now, any questions about this on how we wrote the file and the idea that we're doing line at a time? Okay. So now let's look at a file where we want to do something with this data. So we want to display this data. Okay. I'm going to get rid of all this stuff up to there. We won't have a number of employees because we're going to kind of determine that as we go. I can still call it this, but I can go instead to a read mode. Okay. And for the way the read works, we want to start by reading the first name before we get there. Do an imp file.read line, sorry, read line. We can then say while name is not equal to nothing. And we've done this 1,000 times before. We test before we get into the while. So if it's an empty file, it will never hit anything. Okay. We can then read the rest of the data we need. Okay, we can get the ID being equal to imp file.readline. It's going to go in order. Okay. And then we're going to get department equal to imp file.readline. Okay. Note the file doesn't know what's in it. The file doesn't know what's what. If you mess up and read one more, it'll just read the next name. Okay. So that's all we're doing. We're just getting the information here. Okay. Once we read this, we need to strip the new line characters. Okay. So I'm going to set name equal name.rstrip, that new line character. ID is going to be equal to name.rstrip and the new line character. And then finally the department is going to be equal to, that can't say name. It's going to be equal to department. rstrip, new line character there. That's going to get rid of those. And then let's just say we want to display the record in some format. Okay. So options here, we could say name. Let's tap it over to. The ID. Twice as one. This looks nicer. May not. Print at once. We're going to print department. Again. And that's going to go through all of that stuff. And then when we're ready to go back and do a new record, okay, so we've gone through, we've got the name up here, we've got the ID, we've got the department. IDs are purple, may not be easy, we'll see. So I might do something different with ID. When I get down to here, okay, I have to get the name again for the next go. Okay, the name is going to be equal to file dot read. I have that so I can see whether we're at the end. Okay. I'm going to go ahead and print here as well. Again, just to keep it a little neater. A tab and dashes. Then I'm going to get the new line character, get the new name. If I'm done, when I get back up to this line, it will stop me. When I get back up to the 6, it won't go any further. Okay. Now, with all of this, we want to make sure that we do an file. Okay. Let's see if this works. The 2 records in there, and there they are. Okay. Department looks a little ugly, so you probably want another average of the ones beforehand, but that's the basic idea. Okay. Are there questions? Okay, so there's an in the spotlight there that goes through doing a lot more kinds of things there. Okay, it's worth thinking about how we're going to do things. So, for example, they do a search on this. Okay, so with the search, if we were going to implement a search here based on this file, okay, let's think about how that may work. So we've opened it up here for reading, and let's say what we're looking for. So we can say like ask for a search term is equal to Alex. So we're looking for Alex. Okay. We have to keep a found Boolean there. Then I can say while not found, which allows things to stop. Okay. So when I do that, I'm going to read the first name. Okay, I've got to keep all this stuff in there because I still could be. I'm going to eventually get to a file that doesn't work. Okay, so this is going to be the same. Where I get the name, I get the ID, I get the department, description, new line characters. But instead of displaying, what I'm going to do here is do the search. Okay, so we're actually here going to search. Okay. So the search here is going to be if name is equal to S, the search term that we're looking for. If that's true, we want to print that S is found. Okay. And we want to set found be equal to true. That'll get us out of here. Okay. So that should work to search for this. Okay. But I think the key thing here is, even though we're just doing the search, we need to read in all 3 fields. If not, we could read in the first one and say, oh, that's Bob, that's not correct. So we're going to move on. But we would still have to read those next 2 lines. There's no way to get around it. Okay, we're doing sequential access. Okay. So if I did all that correctly, Alice is found. Okay. We change this to something else. It's not there. It shouldn't print anything at all. So I should have something that does print, but I don't. Let's see, it just doesn't do anything. Okay. So I would need something else there. I need else here. Oh, no, think about that. I don't want to say every time it's not found. So if I come out of this loop, I've got to find a spot where I can know I didn't find it. Okay. So yeah, I'm missing something here. There's no way to get out of this loop if it's not found. So I have to think about that. And the book's got a better example that deals with that. In general, we're going to have to think about that case and have something different for our continue rather than the fact. But that's the basic idea when we're going to search something. Okay. The other thing we can do that the book talks about is to delete a record. Okay. When you delete a record, the best thing to do with sequential, in fact, the only thing that you can do is that you have to create a new file that looks like the old file without what you want to delete. Okay. So if I have Bob and Alice and Carol as the 3 records, if I want to delete Bob, I'm going to create a new file with another name. I'm going to read in the record from the first file, the employee file. Okay. See if it's what I'm looking for to delete. If it is, I'm just going to skip to the next record. If it's not, I'm going to write that to the new file. Okay. And then we're done. We're doing something kind of different than that. So I want to point that out. I forgot to point out the first one. So you're getting more information. If you look at the delete coffee record on page 322, we're having this OS remove and OS rename. Okay. So for those, we have to import OS. Okay. So the OS refers to the operating system. And what the OS library does for us is that it's the interface between Python and your operating system. So it doesn't matter if it's Windows or Linux or Mac or whatever, it deals with it. Okay. So you don't have to know the actual command. You just do those commands and you're able to manipulate the files. Okay. So that's a pretty important thing to know how to do. Questions on this? Okay. Next thing we're going to talk about today are exceptions. Exceptions really are important. We're going to be able to close the loop now on validating input of users. And that's really important. Never trust a user to do anything. Okay. So an exception in computer science means something happens that's unexpected. Okay. That causes the computer to blow up. Okay. So for example, if my program says something like x is equal to 5, y is equal to 0, and then I want to print x/y. If I run this, it's going to tell me here, okay, this is an exception. It doesn't say this is an exception, but this is what an exception does, okay? In particular, the exception we're getting here is the 0 division error exception, okay? So what we're going to talk about are some ways that we can avoid this problem. Okay. First off, let me say that the normal ways we handle this, where we would go through and just do if y is equal to 0, don't do that line, are still your best line of defense. Okay, because division by 0 is not really unexpected. Whenever you divide a number by some variable, you want to make sure it's not 0. Okay. Well, let's go through the process if we wanted to check it this way, because it's a simpler example than the book gives for exceptions. Okay. So when this exception occurs, we can do the following to capture that. Okay. We're going to start with the try. So the try means that we're going to attempt something knowing we need to be watching out for there to be a problem. Okay. If something's not into the try and an error occurs, it's going to throw up red stuff on your screen. Okay, that's all we can do about it. But when it's in a try, we have the terminology is we're going to catch the exception. Okay, so we're going to do that with the exception command. Okay, the most generic is just exception with no other modifiers. Okay, and what the exception, that's not exception, except. That's it. Except is going to capture any exception that you get. You just print generically an error occurred. Okay. So when we run this now, okay, this is better. Okay, I want you to understand why it's better. This is bad on several fronts. First off, it gives some information about the program. It may leave files or other things undone. It's untitled. It looks bad. Your program should never do this. Okay. This doesn't fix the error, but at least it says an error occurred and I shut down normal. Okay. So there's an improvement. Okay. But we can, in general, we can focus on the errors that we're trying to deal with and then give a little more customized help. There are lots of errors that could happen. Okay. So if I were to copy and paste that error, that exception. Okay. So now I've got my try, I've got my except zero division error. Okay. It says if there's a zero division error, go right here, and that's what the problem is. Okay. So you can either put a custom error message here, which is fine. There's also, you can do accept zero division error as ERR, or whatever variable you want, and you can print, that's the standard Python error message, which sometimes are good, sometimes are ugly, just depends. Okay, so now when we get this, so they say pretty much the same thing, but this top message is the one that I wrote myself, and this is what just comes through. And in fact, it's the same thing that comes through over here. Okay. So we can use this whenever we think that there's going to be a problem. Okay. Let's look for another place where there's sure to be trouble, and that's on opening a file. So far, we put the file name in ourselves, but we may want to have a program that, let's do this, our generic, well, like from the homework, the line number thing. So let's say this is a line number printout. Okay. So this one, we're going to start with a file name we're going to ask the user for. We're going to input file name. We're going to let them do whatever they want to do. Okay, they're going to type the file name. We're not giving them a directory listing or anything cool, but they're going to have to know. Okay. So once they've done that, we can set our C equal to 1. We can do for a line in file name. We're going to print that number. I'm going to follow that with a period and a space. Actually, do a period and a tab, followed by that line. Should work for that. Although I want my separator equal to nothing, so it's going to put the number and the dot next to each other without space. Okay. And then I can do my C plus equals 1 or C equals C plus 1 to do that. Okay. So that should work okay, right? So if we have something, we know that run this. So we enter something that works. We know that names.txt should be out there. That was all about. Okay. No, that's not what it's doing. Oh, I never opened the file. Good Lord, losing my mind. So now I want to say end file is equal to open file name for reading. There we go. So now we can say for line in end file, we've got to do this. Let's see if this is better, and then we're going to need to close. Okay, so if I run this now, and I say names.txt, that's going to correctly print that out, right? Okay. But what if something goes wrong? Okay. Gives me a file not found error. Okay. And the book points out that we can do an accept on this error, but there's a more generic error, okay, that's going to be the IO error. Okay. So the IO error will catch this file not found error, but it will also catch if the file is damaged in some way. So before I do, again, I have to identify the line that's likely to cause the trouble. That's line 5. Okay, so I want to make sure my try is before that line. So, I mean, this is new stuff for us to do. Every time we have a file, we need to put it inside of a loop like this, inside of a try block. Okay. And we know we always have to worry about the exceptions. The IO error. And then again, we can say as ERR, print ERR, or we can do our custom. Whenever you've added all of this protection, you want to make sure it still works normally. So if I say names.txt, sometimes you put up so much protection that even good stuff doesn't work. Well, that worked okay. Run this again. Okay. This time I'm going to put in junk. Oh, an issue I should have dealt with. This happened even though there was an exception. I need to make sure it's over here. So basically, my whole program is inside of the try. Run this again. So now it gives me no such file or directory. Okay. Which is the same error from up here. Okay, but by the IO error, it's also, if it were a damaged file, will give us the same thing. Okay. Questions about this? Okay. There are a couple of other things that we can do here, a couple other clauses. The first is an else clause. And this, it hits this if no exceptions occur. Okay, so if I go through from line 5 all the way down to line 11, and everything happened properly, okay, I can say print hits the else clause. Okay. There's also a finally, which hits no matter what. Okay. So again, let's make sure we're clear on the order things happen in. Okay, so if we run this, line 25 is the first one to execute, and it goes up to 3, and then 4, and then 5, and then 6. 6 is the one that could cause an error. If 6 causes an error, it's going to skip down to 13, and then 14, and then it's going to skip to line 20, hit the finally. If there is no finally, it's done, it moves on and closes the program because there's nothing beyond that. Okay. If we do it correctly, we go up to 5 and enter, say, names.txt, which is there. We go to 6, and 6 is okay, so we go on to 7, and 8, and 9, and 10, and then 8, 9, and 10 again and again when we're done with the file. We close the file, we go from 11 then. So 11, we go back up to 8. When we're done with 8, we're going to skip down to the else, and do the else, and then finally to the final. Okay. So we run this to see an example. We run this on something that doesn't work. Okay. The finally hits after giving us an error message. If we run it and it does work, the else clause hits and then the finally hits. Okay. Questions on that? Okay. So now, and I released a video about this morning. But let's say that we want to ask the user to enter a number an integer less than 100. Okay, we're going to print that out. So what do we have to worry about here? What can go wrong? What exceptions could occur in this program? Yep. What error is that going to throw? So it gives a value error. Okay. Again, if you don't know on the test, you don't know, force the error, and then you can just cut and paste the value error. Okay. Which means if I want to protect, I couldn't do this before, right? This is new. We said to assume they were entering an integer. Okay. So I can now put all of this in a try block. That and this. Okay. And I can do, I'm not in Java. Java does a catch. So we do accept the value error. Is that what it's called? Yeah, value error. Okay. Press. Enter an integer. Okay. We can always put at the bottom, it never hurts, except as error should work. I think we can do that. Print error. That kind of covers us no matter what. Okay. So this should cover that problem, okay, although it's not going to fix it. It doesn't like that. So I guess we can say here's an error code. I guess that's why the book does that. Okay, so it doesn't let us try again, but it will end gracefully. Okay. So let's think about if we want to allow them to try again. Okay, so we can put all of this inside of a while loop. Okay. So I'm going to start by saying, let's use continue equals true. I can then say, while continue, keep doing this. Okay, so it's going to keep going. Okay. So it's going to ask for the new value. It's going to hit the accept value error or the accept. Okay. So if it hits either the accept value error or the generic accept, I don't want to change continue, right? I want to keep them in this loop. But if it makes it through okay, I want to go ahead and exit. Okay, that's where the else comes in, right? That's what the else does. So I can go down here and add an else clause, which again, only if no exceptions. Okay, and I can set my continue equal to false. Okay. This is now going to keep me in this loop until I get something correct. Okay. Run this again. If I enter 2.3, nope. If I enter random letters, nope. If I enter 50, we're good. Okay. So this is what validation looks like. Okay. Every time you ask the user for anything that you're going to run through a float or an int or a bool or any of those functions, you need to put it in the try loop, checking for the value error. Okay. Our programs are getting longer. The same program is now longer than it was yesterday. Okay. But we're covering our butts more, which is good. Okay. So there's one other issue with this. Okay, and that's that the number has to be less than 100. Okay. The normal way to do that is just to put an if statement in there and then keep it inside the loop. No. Okay. We certainly can do that, but I'm going to force the example because I want to talk about the assert statement that we mentioned Monday or Wednesday, whichever day. Okay. So let's say once we've entered the number before we print, I want to assert that x is less than 100. Okay. We talked about this with our post conditions for functions. Okay. If this is not true, it's going to throw that assert error. It's going to stop everything. Okay, so let's run it and see. So if I enter a 200, for example, the assert error is going to fire. It's going to be caught by this except, just because we didn't know what else it was. Okay. If there wasn't an except, and what I was trying to do is force us to know what that's called. Okay, so let's run this again. And enter 200. Yeah, the assertion error. The assertion error, I want to catch that separately. Okay. You may have, some of our functions had more than one thing that could cause that to be a problem. Okay. And again, I'm pretty sure the except by itself has to be last because it's going to catch the first one it falls into. So to do except assertion error. Okay, as ERR. And then print the ERR. There is no default error message on the assertion, but I can put my own up here. Okay, so I can put number too big. Okay. So, and again, this is not a function like you would think. There's no parentheses around it. You put parentheses, it works, but it ignores your message. I'll run this now, and I enter 200. You see that it gives this particular error message. That's going to keep me in the loop. Okay. And again, if I enter a 2.3, still keeps me in the loop. If I enter letters, still in the loop. Okay. So it keeps me there until I give it something that it wants. Okay. Questions about this? I released a video that has this exact program on it, so you can watch it separately. I'm also recording this right now. Okay. But validation now means this. The book doesn't always care about validation. I care about validation all the time. The most important thing you can do to avoid your programs crashing. So homework for this time, 6, 9, and 10. So 6 is going to ask you to have a file which contains a series of integers called numbers.txt. You're going to write a program that calculates the average of all the numbers stored in the file. Okay. So for that, you're going to have an exception. Actually, you don't yet. In 6, you assume everything's okay. You just read it in and convert it to integers and get the average. Okay, so which means you have to keep a count and a sum. 9 is to copy over the same program from 6, but add in the exceptions. Okay, so you're worried about the file name being wrong. You're worried about there being an IO error. You're worried about the numbers not being integers. Okay, those are the things we're concerned with. Okay. And then finally, golf scores. It's going to have you do a program that allows you to write golf scores to a text file and ones that allow you to read it in from the file and display it. Okay. That one is not, there's not a separate program, but that one should deal with exceptions as well. Whenever you need exceptions from now on, you should use them. Okay. Questions? Okay, that's all I've got for today then.